Welcome to the last webinar of the Snooze Summer Webinar Series. So my name is Catherine Duclos, and on behalf of the Quebec Sleep Research Network and the entire Snooze team, I just wanted to say thank you for joining us today. If it's the first time that you're joining, well, welcome. We hope that this is useful for you. So just a little bit about Snooze before we launch the session. Snooze was designed to bridge two worlds that often remain disconnected in sleep research. So we have often, clinicians, trainees, sleep technologists who want to have more intuitive and reliable tools that don't require programming expertise. And on the other hand, you have engineers, methodologists, developers who need flexibility to build, customize, and extend advanced analysis pipelines. So Snooze was designed with this in mind to make both worlds coexist and enhance the tool itself. So over the past few weeks, we've been going through more the software interface, and today we're going more on the back end for those that want to customize or extend existing tools within the Snooze toolbox. So Snooze emerged from a highly interdisciplinary collaboration, bringing together sleep researchers, neuroscientists, engineers, developers, and signal processing experts. Nadia Gosselin has been the leader of this initiative. She initiated the idea and the development, and has overseen the development and its funding over the past few years. Senior sleep technologists Hélène Blais, Sonia Frenette have also ensured that the platform remained grounded in real-world clinical and research workflows. Jean-Marc Lina and myself have been advising on how to extend the platform further. And I want to emphasize the central role of Karine Lacourse as lead developer of the platform. She was initially working with David Lévesque, but more recently has been working with Agnès Bazrek-Al-Sadeh and Mohamed Hassan as the core programming team. So we want to say thank you to the funding agencies that have supported the development of Snooze over the past few years. The American Academy of Sleep Medicine Foundation, the Brain Canada Foundation, Fondation de l'Hôpital du Sacré-Cœur de Montréal, the Research Center at the CIUS du Nord de l'Île de Montréal, the Canada Research Chair on Sleep Disorders and Brain Health held by Nadia Gosselin, and NSERC. So today it's meant for not just developers specifically, but really anyone who has a bit more expertise and wants to play with the tools themselves or customize or extend for their workflows. So this will be an English session, but Q&A can be in English or French. If you have questions along the way, you can insert them in the chat or keep them for the discussion at the end. So once again, this is the Snooze Toolbox website and application. And we have a little poll for you. I think I'll stop sharing. It'll make it easier. We just want to have an idea of the profile of people joining us this morning for this special session. So you should be seeing a poll right now that you can complete in the next few minutes, and then I'll share the results with everyone. And in the meantime, I want to introduce the three speakers that will be part of this session. Actually, I'll wait to do that. I'll let you read the questions and answer them first. So mostly new users to Snooze who want to learn how to use Snooze more effectively and have either never or rarely used Git or code sharing platforms. And have no experience. Everyone's reported having no experience on user interface design and development. Okay, very interesting. All right, so I'll keep this window open just for the next minute as I introduce our speakers. So Karine Lacourse graduated with a master's degree in engineering with a focus on health technologies from École de Technologie Supérieure in 2014. She's an algorithm designer with extensive expertise in PSG and signal processing. Over the last 10 years, she's developed and validated biometric algorithms at the Center for Advanced Research in Sleep Medicine using MATLAB and Python, including sleep spindle detectors. She's currently dedicated full-time to the development, documentation, and training of the Snooze toolbox. We have Annie Vazregarzadeh, who has been a research assistant in my lab for the past 4 years. She holds a master's degree in electrical engineering from Shiraz University of Technology, where she developed EEG-based fatigue detection methods using convolutional neural networks. Over the past several years, she has worked extensively on EEG signal processing, brain connectivity, sleep, and disorders of consciousness, and has been a key contributor to the Snooz Toolbox for over the past year and a half. And we have Mohamed Hassan-Azad, who's a software developer at the Center for Advanced Research in Sleep Medicine with more than 7 years of experience in signal processing, machine learning, scientific programming. He completed his master's degree in biomedical engineering in 2025 at École de Technologie Supérieure. And here at the Center for Advanced Research in Sleep Medicine, he contributes to the development of the Snooz platform, including its architecture, algorithm design, and sleep data analysis tools. So my understanding is that all three of them will share the spotlight today to present you the back end of this Snooz Toolbox. Thank you for joining us.
Well, finally, hi everyone. I'm happy to present this webinar on developing in Snooz. As Catherine said, I will be presenting with Mohamed Hassan and Anya. Just have a short problem with my window. So today I will present an overview of Snooz from both the user and developer perspective. We'll start with how to get started with Snooz. Then we will look at the Snooz structure to understand the main concept behind Snooz and how the different components interact. Next, we'll explore the user and developer interfaces, followed by an overview of the Snooz data format. We'll also discuss on how Snooz can be deployed on high-performance computing environment. The second half of the presentation will focus more on developers, including the available tutorials, the development environment, and how to package and share your own Snooz tools with other users. Finally, we'll leave some time at the end for question and discussion. So it's possible to develop in Snooz with some limitation using only the Snooz installer. So as a regular user, you can start by downloading and installing Snooz. We presented many times yet, but still, please visit snooztoolbox.com and complete the form in the download section. You will then receive an email containing a link to the download the installer. The link should direct you to the last version, which is beta 3.00 right now. The email is usually delivered within 15 minutes. If you have any issue, please contact us. For user we have already installed Snooz, you can easily update it from the user interface. Just go to About Snooz under the Help menu. This pop-up window will appear and you simply click on your operating system. Do not forget to close the toolbox before reinstalling it to ensure a successful installation. So let's start with an overview of the Snooz architecture, which is built around three main concepts: modules, processes, and tools. Here's a simplified schematic illustrating the Snooz structure. So at the base of the pyramid are the modules, which serve as building blocks, each designed to perform a specific task, such as reading a file or filtering signals. Above the modules are the processes, which combine multiple modules into a complete analysis workflow, such as reading a file, filtering signal, and writing back the results in the file. Finally, at the top are the tools, which provide a step-by-step user interface for configuring settings and running underlying processes. In other words, they provide a user-friendly way to configure and execute a complex analysis workflow. The blue triangle grouping the tools and their components represent a Snooz package. While its structure follows the conventions defined by the Snooz framework, it remains independent of the core framework, making packages easy to add, share, and distribute. Now let's explore the two complementary interfaces available in Snooz: a user-friendly step-by-step interface for end users and an advanced developer interface that exposes the underlying building blocks. Snooz is designed as a toolbox, so the first step after launching it is to open a tool you are interested in. The tools are organized into 3 categories: pre-processing, processing, and post-processing, all in the menu. When you open a tool, the tools view opens, and the first page displays a short description of what it does. On the left, you will find the setup steps. You can navigate through them either by selecting the step directly or by using those buttons. So the right panel here displays the settings and the option for the selected step. Once everything is set up, you can either save the workspace to run the analysis later or press run to start it immediately. The workspace is a JSON file that contains all the parameters defined in the tool, including the path to your PSG file if they have been added. This saved workspace can then be opened back into Snooz by the menu File Load Workspace, allowing you to reuse the same configuration without having to redefine the tool settings. I would also like to draw your attention to the Give Us Your Feedback button. Clicking it opens a form in your web browser where you can rate the tool and leave comments. Please do not hesitate to use it. An email will be sent directly to the Snooz team, allowing developers to review your feedback and improve the tool. All Snooz documentation is maintained on Read the Docs and linked to one of our public Git repositories. The documentation is versioned across releases and can be accessed directly from the Snooz interface by clicking Read More. This setup makes it easy for developers to write, update, and link documentation to their tools in a consistent and versioned manner. All tools in Snooz follow this framework, including the step-by-step interface, the feedback mechanism, and a direct access to the documentation. As a developer, creating tools in Snooz allows you to benefit from this feature automatically. Another interface is also available via the process view. It is intended for experienced users or developers, providing access to the building blocks. Here we can see the interconnected modules that make up the analysis of the current tool. A process view like this one can also exist without any step-by-step interface, meaning developers can start creating the process and running it without creating a UI tool. The right panel, I have to move my window. Let me see. You see this, right? You see the picture? Yeah. Okay. So the right panel here lists all the modules available in the packages distributed with Snooz. We'll explain later how developers can add their own packages. You can just drag and drop the module you're interested in the process view and connect input and outputs using the left mouse button. So to help users explore all available modules, we document their description and categories on Read the Docs website, enabling automatic search across all modules. So each module in this process view can be as its own set of views, which can be accessed by double-clicking on the module. So the settings view is used to define and edit the module parameters. The results view allows you to explore and visualize the output generated by the module. And finally, the logs view displays processing, messages, warnings, errors, and other information produced during the execution. In the next few slides, I will show examples of these views taken from 2 modules: the sleep cycle delimiter, which divides sleep stages into sleep cycle, and the oxygen desaturation detector. These examples will illustrate how the different views are used in practice. Here is the settings view of the sleep cycle delimiter. This view is used to define user editable parameters. The same view can also be linked to the step-by-step interface for the tool. A default settings view is automatically generated when you create a new module, but it's not descriptive enough to be shown to user. So the developer should create a custom one to make it useful, especially if they want to use it in the step-by-step interface too. The result view shown here for the oxygen desaturation detector can be used to explore the signal. In this example, the oxygen channel is displayed along with its low-pass filtered and gradient versions. This interface allows user to jump to a specific time, elapsed time, adjust the time of the window's length, and modify access setting. Some results views are much simpler than this one, but it's important to understand that developers can design fully customized viewers for their key module depending on their needs. Finally, the logs view shown here displayed the PhD file that was read and the generated output and the processing time. When an analysis fails, the problematic module is shown, it can be easily identified in the process view by a red indicator. So modules that completed successfully are marked with a green indicator, while modules that have not been yet processed are marked with a gray indicator. So double-clicking on the problematic module allows you to get the logs view. It displays the error along with the corresponding line of code, helping the developer to fix the code. So developers can curate like custom process and have access to many views directly. So I will let Mohammed presenting you the PSG format supported by Snooz.
Okay, hello everyone. I'm happy to present and continue the presentation. So in the next 2.5 sections, I'm going to talk more about more details of the data formats and how run Snooz on high-performance computers and so on. So here, let's talk about the PSG formats supported by Snooz. So just if I can, yeah. So Snooz supports European data format for polysomnography signals and a specific tab-separated value file for annotation. Snooz expects a TSV file containing 5 columns to describe the annotation, the group, and the name of the annotation, the onset time in second, and the duration in second, and finally the list of channels associated with the annotation. Also, Snooz supports 2 additional formats, mainly for the SIAMS members, which are the Harmony up to 6.2 and natives up to version 9.1. For unsupported PSG inputs, developers have several options to extend supported data formats in Snooz. First, annotation converter. So annotation converter and importers are 2 tools that are already available in Snooz for users to easily convert their cohort to a format compatible with Snooz. So users with different data formats, including EDF+, XML, stage vectors, like text files and other annotation files with basic details such as name, onset, and duration, can easily convert their original annotation file to a Snooz compatible format. So if the existing converters in Snooz are not suitable for a specific format, a custom converter can still be developed in this case. And the workflow remains the same, so convert the cohort first and then use Snooz as usual. And alternatively, as the final step, if still your data is not compatible with Snooz, there's possibility to extend Snooz by implementing a dedicated reader that directly links the data structure to the internal Snooz object. In this case, the Snooz can read the format natively without any prior conversion steps, formats are registered through a resource folder, which allows Snooze to automatically detect the supported data format. For example, in this case, now for now we support EDF, Natus, and Harmony Stellate. So Snooze can easily detect which input file format existed and selects the reader corresponding for that specific format. So this one can be any one, for example, for MNE, even MNE library and any other format. So this was a brief description of the data formats that they are accessible for Snooze. In the next section, I'm going to talk about HPC's high-performance computers and how Snooze can be run on those. So in the next slide, we'll explain the details of how user can run Snooze on headless mode without any UI on high-performance computers like Compute Canada, specifically for huge cohorts that you need to run for several days, for example. So to start using the headless mode in order to run Snooze on HPCs, you need to follow these steps and prepare your environment first. The first step is setup and connection. So you need to prepare some prerequisites like SSH connection and two-factor authentication that Compute Canada, as our example here, needs those requirements. The next step would be environment configuration. So you need to prepare your Python virtual environment and dependency setups on Compute Canada environment. And then when everything is ready on your Compute Canada account, you need to apply a file management, which is like organizing the folders and be aware to put your data in a specific folder in a Snooze workspace. And finally, everything is ready. Your data is there. Your workspaces are there. So you only need to run with a specific command that I'm going to let you know in the following slides. And if also you're interested in running in batches or you have a big cohort to run, you can just do it all together by just sending the script to the Compute Canada. And if you are interested in more details, they are all available in Snooze docs, as Karen mentioned. So the prerequisites are as the following. You need to have access to an active Compute Canada cluster like Narwhal, Cedar, Graham. And when you have the access, you for sure you have your login credentials. And the only point about Compute Canada is that you need to be aware that with your account, you can access and you should activate your two-factor authentication like any other apps that right now need the two-factor authentication. And when you are set up with Compute Canada, you need to prepare your valid Snooze pipeline, the workspace with the format of JSON file that I'm going to talk about that in the next chapter. And finally, when your workspace is ready, you need to make sure that the package versions for SIAM's modules and SIAM's tools are compatible with the one that is written in your workspace. And then you're ready to go and run your analysis. About the organization that I mentioned earlier, you need to be, when you clone the Snooze toolbox from the repository, there is some organization like this. It's not important to know right now, but just I wanted to mention that there is a folder specifically for Compute Canada that you need to put your workspaces and your data there. And you don't need to care about the rest, and just to make sure everything is there. And in the next slide, I'm going to say how we can run Snooze with the command when they are there in the specific folder. So you're able to run Snooze from Compute Canada when everything is set up. So you need to verify your created Python environment on the connected cluster first. When it's ready, but just write in the following command and don't worry about it if you don't remember it right now. They are all there in the documentation and it's easy and it's very user-friendly for you. And then navigate to the Python directory where the main Python files of Snooze are existed. And finally, run Snooze with the absolute path to your workspace using the headless mode, like the following command. So basically, with This command, when your files are in the specific folder, you are able to run Snooze on your cohort and easily without any problem. So I guide you to just go for documentation for more details. In the next chapter, we are going to talk about developer guide. The part A of this chapter, I'm going to walk you through the documentation, how to set up your development environment, and the example packages in this new template modules, tools, and the first look at apps. And part B will show how to create your own modules, tools, and apps using the utility script that Hani will take a little bit. So getting started with the development in Snooze can be quite challenging as there are several important aspects to consider. We don't know each developer's background that much. We had an idea of their background with the pool, but I will go through some maybe high-level explanation of the Snooze backend. So the learning curve may be a bit different based on the different participants about what are the Git repositories, Python, object-oriented programming, and designing with the Qt graphical interface. And as I said, documentation is intended for less experienced programmers, but is specific to the Snooze framework. And today we'll mostly focus on 3 highlighted points here. I will activate these 3 highlighted points. Developer installation runs from the source code and explore the examples. So the Snooze documentation guides you through the steps required to install and configure your development environment. This includes creating a Snooze workspace to group together the Python virtual environment and the source code repositories. We provide a requirement file for the Python environment directly in the Snooze toolbox. So when you have the Snooze toolbox ready, you can see the requirements and you can install it easily with a command line. And additional repositories are also available. The Snooze package SIAMs includes SIAMs tools currently under development. Every new modules and tools that we are developing are there, and they would be updated. And a Snooze package template can be used as a starting point to create a complete new Snooze package. So you can create your own modules, your own tools, apps that I'm going to mention in the next slide. And to run Snooze source code, only the Snooze toolbox repository is required. So you have some basic, actually built-in packages there in the Snooze toolbox that you can just run Snooze without any of the other packages. And our development documentation also includes configuration instruction for VS Code for development. So I'm not going to go through this since we don't have that much developers right now. So to explore an example, we suggest exploring the provided example package template before starting your own development. So in the Snooze repository, you have access to the Snooze the example template. These examples are simple, well documented, and designed to help you understand the main concepts of the framework. Once the repository has been cloned, you can add the example packages. So these 3 example module package, so easily, as Karen mentioned before, from the setting of the Snooze, you can use the add from folder button and add the example modules, example tools, and example package to your Snooze setting. And just by clicking them, you can activate them. And the example toolbar would be here, and you can access to these 3 built-in examples for your understanding. Yeah. And it was the first time that we have mentioned applications today. Hani will describe them in more detail shortly, but for now, you can think of them as tools that do not have a step-by-step Snooze interface presented earlier. Instead, they are standalone applications that can be launched from within Snooze. For sure, you will have more details in the next slides. The package structure for modules include a description file that groups the package name, version, author, and a list of all included modules. So actually, when you open the, for example, example module package, you can see a JSON file, which is the description file. As I said, it has all the information, some basic information about the module, and it is a human readable file. So as you can see here, you can see module parameters like the name, the label, the category of the module, the inputs of that module, and also the outputs. And for each module, you have a specific folder, and you can write the actually main core of the algorithm in the module description folder, in the folder in the name of the module that has Python file in the name of the module that you can, this is the core of the algorithm. You can change it and make it compatible for your use. And you have the result setting view and the results view that you can change the UI of the setting view and the result view, as Karin showed you those views, and they are easy to modify. And so the package structure for tools is something similar to modules. It also includes a description file that lists all the tools contained in the package. Each tool has its own folder and its own description file. The structure is almost similar to what we had before for modules. The tool description file defines the tool's steps as shown in the this panel. So the tool description file, you can see the first step, the second step, and the introduction. So you can just manipulate them, change them based on your needs. And I assure you that you don't have to create this structure manually. It seems to be a major modification and for a lot of details. But part of this, all the templates are generated automatically by a command line. Just you need to follow some steps easily and human readable. And Honey will present it shortly. And the analysis pipeline is automatically created by Snooz, and you can just change it based on your need, based on the template. So this was the first part of the developer guide. The second part of the developer guide is from now on, and Hania will take the lead of that.
I will start with section 6, part B. In part A, you saw the developer setup and the structure of the example modules and tools in the template repository. In part B, we move from exploring example to creating your own building blocks in Snooz. So you don't actually need to create everything from scratch. Snooz provides a utility script, Python main-utils.py. In your package repository, this script automatically generates the required structure and description file. It guides the user through the process by asking proper questions and then generate a corresponding structure and the definitions automatically. So this script can also be used to create a package, a module, a tool step, an application, or a package release for sharing. In the right side of the screen, you can see the example of the questions and answer involving creating a module. The scripts ask which package the module should be added to, the name of the module, and its inputs and outputs. So far, we have found how to build tools in Snooz. Now I want to talk about when we should build a tool and when we should build an app instead. So the main question is simple. Can the user define all inputs before running the analysis? If the answer is yes, a tool is usually a better choice because the user goes through steps, set parameters, and run the pipeline. And that works well for things like power spectral analysis, slow wave detection, or connectivity analysis. These are the pipeline that has batch style workflow where you know what you want before clicking on run. But if the answer is no, the app is usually a better choice because the user needs to see the data first, make decision based on what they see, and maybe go back and change something. Like an interactive workflow. That's what we did with the AG inspector and oximeter inspector. And the tool, the table you can see in the screen, compare the tool versus app. So actually, a tool is built on a process and the steps. You can reuse a Snooz step-by-step interface. So development effort is actually lower. The flow is linear, step one, step two, and run. But the app is a standalone application inside the Snooz with a custom UI. You design the whole interaction yourself, so the effort is actually higher, but you get the flexibility. The user flow can be iterative and not just step by step. And so for configuration, tools use tool.json plus the process, and app use app.json. So if I want to summarize, Python pipeline you can define upfront. Tools a better choice, but if you want to inspect, annotate, or interact with the data, the app is a better choice. And in the next slide, you will see a short demo of EG Inspector, an example app in the Snooz. You will see why we chose an app instead of a tool. The user has to look at the data and make decision step by step.
Here's an example of an app integrated in Snooz, EG Inspector. This is an interactive application for visual quality control of EEG signals. In this demo, I have loaded a recording. First, I review the channels and identify non-brain channels and confirm my selection so that can be excluded from further analysis. Next, I inspect the EEG traces and mark channels contaminated by noise. The signal is then segmented into epochs. I go through the epochs and mark noisy segments for rejection. Finally, I review the overall signal quality using the power spectral density, or PSD. When I am satisfied, I save the annotations. These annotations can be used in downstream tools, such as connectivity analysis. This is just one example of what an interactive app can look like in Snooz.
So when you saw in the demo, the app was fully interactive and the user chose what to remove based on what they see in each step. So now we will discuss how to create an app in a Snooz. The starting point for creating an app is similar to creating a tool. You use the same helper script. The step you must take is to just close the Snooz, open a terminal in your package repository, and activate the virtual environment and run python main utils.py. In the option, you will see an option is in the fifth. If it's in the fifth step, create an app and enter your package name, an app class name, label, and menu category. So Snooz generate a folder with the basic file you need. You will see in the right side of the screen in the table the main file that Snooz generate after these steps. The important one are app.json, which tells Snooz this is an app where it appears in the menu. An app.view.py where you put your logic and content button and plots and everything. And UI app.view.ui, the layout you design in Qt Designer. And the UI.py file that is generated automatically, so you don't want to edit that by hand. And once you register the app in your package JSON, launch Snooz, and it should appear in the menu that you chose. So also, even in the app, you don't have to rewrite everything from scratch. You can reuse existing modules. For example, Oximeter Inspector and EG Inspector both use PSU Reader to load data and PSU Writer to save the data, same as other Snooz components and tools. And in the slide, you can see the oximeter files as a reference. It starts from template, then we added oximeter draw area for the custom plot and a channel selection dialog. So our advice, if you want to create an app, is to start simple, open a file, show one plot, and then add interactions step by step. And more details about the creating an app is in the Snooz developer documentation under creating an app. So now we have seen how to create modules, tools, and app. In the next step is how to share them with other Snooz users. In this section, I will explain how to build a release package with the same utility script that I mentioned, and how sharing and distribution work in the Snooz ecosystem. So to share a package, you can use the util script and select create a release package. This will generate a release folder with the version appendix as a suffix. You can then share this folder so that other Snooz user can add it to their installed version of Snooz. But there is an implementation point. If the package uses extra Python libraries, those libraries must also be included in the Snooz bundle so that everything runs correctly for the user. To create a new installer, you need FBS Pro, a build system used to package and generate cross-platform application installer. The installer can be built through like GitHub Action for Windows, Linux, macOS 64, macOS, and ARM 64. And also the Snooz license is GPL 3.0, a free software license that allows use and modification, but requires that any redistributed version remain open source under the same license. So the goal is to facilitate sleep analysis and collaboration. However, it would be fine if a sleep lab may choose to develop its own package and share it with a specific user, since packages can be added independently of the Snooz installer. And we try to keep the previous version of CM's package in the Snooz bundle to reduce the maintenance work. However, some architectural change are not backward compatible, so all our Snooz installer are still available in the release section of our Git repository. And we welcome contribution, whether it's suggestion, new feature, or developing new tools or app to improve the Snooz. If you are interested in collaborating, please contact us at email you can see in the screen right now. And we are happy to discuss ideas, development, and how your work can fit into Snooz ecosystem. And here are the references if you would like to more about the information. And thank you for your attention. We will now be happy to take any question you may have.
Thank you to all three of you. Ben, merci beaucoup d'avoir été présent aujourd'hui, présent et présente. Thanks for joining us. We hope it was helpful for everyone. And as Nadia mentioned, we'll have the recordings made available soon on a YouTube channel, but shared through the Quebec Sleep Research Network, so you can see it and rewatch it and share it as needed.